this is Corey Glenn. I'm going to be showing today the new Shining 3D printing setup that I've gotten. And so this is the Accufab Cell 3D printer. This one was just released, I think, at the midwinter meeting. This is the new Accufab Wash and then the Accufab Cure. And so they've done a nice job of having a whole ecosystem put together. So I've had this for a couple of weeks, really just starting to learn all the nuances of it, but I've been really happy with it so far. There's a few features that I'm really excited about that have made my life a lot easier. And so let's just kind of go through and show some of the things on this, and then we'll do a print, and I'll just show you some of my favorite features about it. So the printer itself, you know, it's a high volume printer, so you can see the build plate size right here. So you've got a large build plate size. It's a really solid connection in and out. The resin tank, you know, it's pretty straightforward, easy to remove, has the lid and everything. One thing that I really like about this is that it comes out of the box with an extra build platform. So you've got an extra small format build platform as well as a additional tank. And so the reason this is nice is because if you're doing some of, like, say, the crown bridges, you're gonna print hybrids or inlays, onlays, crowns. You know, those materials are super expensive, and so generally you don't want to buy them in like a liter volume. So usually you're getting like a 250 milliliter bottle, which if you're using a build platform that's full size, that's not enough resin to even get the tank to its minimum level. And so having an extra small build platform allows you to use a lot less material, and then, you know, you're gonna just use a smaller build plate. They're easy to switch out. You just got to tell the printer which platform and tank you're using, but that's really about it. Everything's metal, very solid. This ceramic build plate is very nice. You know, it's more durable, holds up better over the long term. But I'm going to show this today with the full-size build platform. And so the printer, you know, you can connect it wirelessly to your network. You can hardwire it in. You can use a USB stick. So really any of the connection options that you want. And it's a very fast printer. Now, the material I'm going to be printing with today is the Dental Model DMO3. They do have their own materials. They're very affordable. Really love that. This particular material that I've got in there right now is not one that's intended for speed. This is like a very high detail resin. So if you're trying to get absolutely perfect, let's say crown and bridge die models, where you've got to have super good tolerances, this would be a good resin to use, but it's not the fastest out there. So I'm not going to really be demonstrating the speed of this printer, although it is a very fast printer. If you are using the resins that are intended for that purpose, you can get orthodontic models in about 14 minutes, which is just blazing fast. So very impressive. You know, one of the other cool things that they've done is they've used some development to make their light intensity and accuracy be much better across the entire platform. So usually you're dealing with a single point projector, and so your most accurate position to print at is going to be in the dead middle of your build platform. And as that projection beams out to the edges of your build platform, typically you suffer a little bit with the accuracy. They have figured out a way to collimate their light where it gets an even distribution of that light without the distortion that happens around the edge of the build platform. So that's really impressive. You know, overall build quality is great. Now, I would have never thought this when I first got this, because usually when I tell people about printing and everything and they're concerned about cost, I'll tell them if there's one part of the printing system that you could probably skip out on, it's the wash unit. Because to be honest, at the end of the day, washing is just simply washing. You can just get 2 little mayonnaise jars of alcohol, and that's oftentimes what I do. I have several wash units. Honestly, I don't use them very much because they're a lot of maintenance and they tend to be greedy with the alcohol usage. I'll just use 2 little bins of alcohol, one dirty, one clean, and I'll scrub it in the dirty, and then I'll come and scrub it in the clean, and then cure it, right? And that gets the job done. There's nothing wrong with that. So I was surprised to find that the wash unit is actually one of my favorite parts of this equation, and not for the reason you would think, because, you know, it washes, right? There's a fan blade in the bottom of this. You've got your alcohol tank right here, which is easily removed. It does have, I don't know if you can see this on the video, but it does have this lid right here. So the build, or the wash basket is going to drop down in this, but that's spring loaded so that when it comes back out of it, your alcohol's covered. You're not going to have to worry about evaporation issues. And it's, you know, easy to change out because you simply pull this thing out and you can dump out your old alcohol to distill it or dispose of it, put new alcohol in. So that's all great. Again, it washes with alcohol. But here's my favorite part of this. So this is your basket that the prints will fall off into, but one of the biggest hassles with 3D printing, especially smaller or thinner objects that you might print without supports, has been the removal from the build plate. Okay, so if a model is pretty thin vertically, especially if it's over a big area and you've not used supports, which is often the case when you're doing like clear aligner models, you're trying to do a bunch of them very quickly, so you're not using supports. Those tend to be very easy to break when you're scraping them off the build platform, right? Because you've got a build platform here and your scraper is coming in at an angle. So what happens is as you get up under that lip, it ends up bending it a little bit, which can either distort it, or a worse scenario is it actually breaks the model as you're trying to remove it. So removing stuff has always been a pain in the butt for me when I've done printing on various platforms, because depending on the model, you might end up breaking your model or you might end up damaging your build plate. And most of my printer build plates are just beat to smithereens. They've got gash marks all in them for me digging at them. Some resins stick on there really bad. So one of my favorite features of this is that after a print's done, you can actually take your build platform and just drop it in right here. It holds really securely, and just tell it you would like to remove the print and wash it. And so when you do that, you turn it on, and this is going to go down, and I'll try to show it on the video, but there is a worm gear drive on each side right here that has a blade. And so the platform is going to drop down, and that blade will actually come across perfectly even with the build plate where you can't get the breakage and everything, and it will actually separate your models off the build plate very cleanly without breaking them, but also not damaging your build plate. And that for me has been a huge benefit. You know, I'm a super big fan of that aspect of this printer setup. Once they come out, you know, it will have been washed. The whole assembly will raise back up out of the alcohol. Your prints can sit here indefinitely while you let them dry if you want to do that. And then of course you can take them out from that and put them into the Fab Cure. Now the Fab Cure, it's a curing oven, right? So it's going to have UV light projected from all sides here. It's got mirrored walls here so that you get a really good distribution of light. All of these products are, what would you say? They're all integrated, meaning you can just tell it the resin that you're using and it will cure or wash or whatever for the right amount of time for that material. And so you've got a rotating clear plastic plate here. Again, it allows the light to get everywhere, but that rotates around so that you don't get hot spots on your prints and uneven curing. So the printer's great. The wash I really, really like. That's probably my favorite part of the whole equation, which really surprised me. And then the curing unit's great as well. You do have a little accessory box here that's going to have, you know, gloves. It'll have your squeegee. It has lens cleaning equipment. You know, scrapers, all of that fun stuff, extra parts that you might potentially need. So nice packaging. They've done a nice job on all of that. Another nice thing that I like about this is that they haven't made it a closed system, meaning that you can only print with their materials, because that's always been an issue with many of the printers I've used. Is if you go with a completely open platform, oftentimes you're having to figure out your own resin profiles, which is a lot of trial and error. Most people are not going to go through that trouble. They have made this to work with their resins, obviously, but they've also gotten with many other companies to do approved profiles within the printer for those materials. Many of the big brands on the market. And then beyond that, something that many printers that are you know, complete systems won't let you do is actually generate your own custom profiles. So as much as I hate having to do that for everything on some of the open platforms and figuring out my profiles, you know, in my position, a lot of times I'm getting these crazy resins from small no-name companies that are really cool, but there's no printers out there that have built-in profiles for them. So I have to figure out my own profiles. So the printer does allow you to save your own custom profiles for certain materials that may not be in the ecosystem. So they've really kind of done a great job on all of this and put together a nice system. So let's go ahead and do a print on this, and I'll show you the software while I'm at it, because they've done a nice job with their software as well. So I'm going to launch the Accufab software. And they've done a really nice job with their software. It's very intuitive. It steps you right through everything. So this initial page, you're telling it what printer you're using. You're going to have, the very first time you use it, put in your printer serial number, but all these things do communicate, so you won't have to do that every time. Are you using the large or the small platform size, and then tell it the material you're using. Okay, right now I don't have any of the other materials in here, but I've got the shining materials in here, but again, it does work with other companies' materials. And we're using the DMO3 model resin. This is a very high accuracy resin, not intended for speed. This would be for like printing your crown and bridge dies and things like that. So when I look at the resolution, you can see it's only got the option for 50 micron because again, this particular resin's not intended for speed. This is more about accuracy. All right, so we'll go ahead and click next and go to import our files. Alright, so we're going to go to the folder here and hit Open File, and I've got 3 ortho clear aligner models that we're going to import, and then there's also a calibration object that I'm going to print just so that I can test what the accuracy of the printer is after we do this. So let's go ahead and click Open, and the files are being brought in. And then like other premium softwares, this one is going to tell you if you have problems with the meshes of your models. So 3 of these actually have holes in them, the ortho models, and so I can just simply hit one button and it will repair those holes. And now everything is printable. Now let's go to layout, and so obviously 2 of my models are outside of the build plate area, and so one of the nice features that this has is the ability to do what's called an auto layout. So if I just hit this button right here, it's going to automatically position my models to fit most ideally within the build plate area. So you can tell it how much spacing between models. I'll click confirm. And as you can see here, it has laid these models out to fit within the ideal printing area. We'll confirm that. And now we can do any fine tuning that we would like. So as you can see here, I do have a flat plane cut on the bottom of these, and so if I wanted to print, say this one's supportless, I can go up here to the rotate menu and say let's indicate the bottom plane, and then this will just let me orient right to the build plate whatever I'm wanting to print supportless. Okay, so we can do that, and then I do want you to see the support. So I think all of these would print supportless if I wanted to do it, given this flat plane, but I really do want you to see the support profiles because those are awesome. That's one of my favorite things about this. Just to show you a couple of other things they have on here, you can change scale, move, rotate. You can insert your own drain holes. That's a really useful feature. You can have it do it automatically. You can have this one button where if I was to indicate a model, now these are already hollowed so I don't need to, but if I wanted to say hollow a model, I wouldn't necessarily have to go to Mesh Mixer or say Blue Sky Plan and do that. I can with one click make that model hollow and build a honeycomb support structure inside of it so that it will really print ideally without supports. And then you've also got this gum shell extraction, and to be real honest, I haven't used that yet, so I don't even know what it does. So it's new, I'm sure it's cool, but we won't mess with that right now. Build plate's laid out well, and so now we can go to support, and as you can see here, it's checking these, and it's saying that these 3 actually are not really ideally set up for supportless printing. I would have thought they were, but, and honestly I could probably just ignore that and move forward, but I'm going to go ahead and put supports on these because this one will still be a good test of showing you how well that model remover works on the wash unit. And so for these units, I'm going to go ahead and tell it that I want to use the default support right here. So I'll generate, And I could generate supports on everything at once, but because I don't want to support this one, I'm not doing that. So I'm just doing them individually. Alright, so I want to zoom in here and let you look at these. Their supports are awesome, and it's all native within this software. I don't have to go to any cloud thing or anywhere else or external slicing software. It generates these supports, which are super thin, and you'll see when I print these things are going to just remove off the support structures just with finger pressure. Really nice. I won't have to get a burr or do anything like that. The bumps that are left behind from the supports are virtually negligible. You can't hardly even tell that they were there. So I love that aspect about it for high precision parts and just for simplicity of removing things. Okay, so with that done, we'll now go to slice. And as you can see here, it is ready to print. Tells us it'll be about an hour-long print. Again, this is not a speed resin, and it's at 50 microns. So we're going to go ahead and click print and send this over to the unit. And this is hooked up wirelessly, so I'm not having to do a jump drive or be hardwired into it. This will go directly over to the printer. Alright, so as you see, the print has transferred over, or it is in the process of transferring over. And now it will begin printing. Okay, so our print has finished, and now we can go ahead and go through the wash process. So what I'll do is just open the lid up. You know, you don't have to do this, but I'll usually take a squeegee and just try to remove whatever excess resin I can, just to not dirty up my alcohol prematurely. Alright, so to remove the build plate, you just lift the latch here, and then you can see our prints are underneath. And I'm going to pause just a second and squeegee off the underside, which I can't do one-handed. So I just squeegeed off whatever excess I could. Here are our prints, and now let's show probably my favorite part of the system, which is the wash and print removal unit. Okay, so you can see it slots in there really nicely, has a definitive seat. We're going to go down here, turn it on, and you can see it's already set to cut and wash. You could change it to cut only just to remove your prints, or you can do wash only, whichever you want. If you wanted to remove them with a scraper and then just drop them in the basket, you can. We're going to tell it we're using that platform. Alright, now I want you to be able to see in from the side here. So I don't know how easily you're going to be able to see this, but what's happening is as that turns, it is pulling a knife across the build plate, which is then, you can see here it comes, which is going to then separate the models from the build platform. And again, it does it really cleanly, where you don't end up having to scrape and get your build plate all dinged up. And so once it makes contact, it really slows down and it puts high torque on it just to get under the lip, and you'll see these things pop off. There one's letting go. Correction, so they've all let go. They're all down on there because they were all connected via the supports. So now that the cutter has done its thing, it will now drop them into alcohol, and it will turn the blade on, and it will agitate that for whatever the prescribed time is for this particular resin. Okay, so the wash unit just finished. It was about 3.5 minutes of washing, and once it does finish, the whole assembly just comes back up out of the alcohol. You can see here are our newly washed items. All right, and so what I'm going to do is I'm going to just sit here and let these drip dry for a minute, just because you don't want to put a model that's still soaked with alcohol into your curing unit. So I'm going to just let that cure and drip dry, and then we'll take them out and put them in the curing unit. Okay, so I've let this drip dry for about 5 minutes, and you can see my models are mostly dry. All that alcohol falls back in, and that lid that's over the alcohol actually directs that whatever drains off back into the tank. But this is what I want you to see. So before I cure it, I want to remove these supports. And so I've broken the models apart. I've not touched these otherwise, and hopefully you can see the support structure. Now watch this. Feels like you're undoing Velcro. Alright, and that is your support removal. Alright, show you another. And again, these are skinny, skinny little models, just tall enough to get an ortho aligner made on. Alright, so that's it. I'm going to toss the supports there into the trash. I've also got the little calibration file that we made. And so now I'm just going to put all of this into the curing oven. Tell it the material I'm using, and then start. So this is going to be a 7-minute cure time, and I'll update and we'll check the accuracy of them once it's finished. Okay, so we just finished curing. That was about 7 minutes. I wanted you to see the print up close. Hopefully that'll focus. There we go. And you can see very high detail, no visible layer lines. Look at how cleanly the supports peeled off. All right. And then here's what I'm going to do to check the accuracy. So I've got this little calibration jig that I've made, and what I'm mainly concerned with is the tolerance of holes. Like, you know, obviously I do surgical guides most, so I want to check the accuracy of these holes. Now they're printed, and the STL is designed to have holes of 2, 3, 4, 5. And so what I've got here, this is called a pin gauge. So in the engineering world, if you're trying to check the accuracy or the size of the hole, you can't do that with calipers. Okay, so in the engineering world, they use this. This is called a pin gauge. And so it's got these individual pins. Now they are in inches, but they go every 1,000th of an inch. And so obviously a 5mm pin is not going to fit in the 5mm hole, right? There's zero clearance right there. 5mm is 0.197. So what I'm going to do is go grab 0.196, which I believe is this one. All right. And 0.196 is 4.978 millimeters. So if you do the math on that, that's basically 22, am I doing that right? Yeah, 22 microns smaller than 5 millimeters. So if this one goes, that would be extremely impressive. And it definitely is tight, but I'm in there. Yep. Now this would be tighter of a tolerance than you would want for, say, your crown and bridge dies or something like that. But I mean, you can see I am doing this with finger pressure. It's not like I'm using pliers to jam this thing in. All right, so only 22 microns of clearance. That's pretty impressive. All right, I'm going to take this one out. Let's do one of the other size holes, because what I found over time is usually the smaller the hole gets, the more it will tend to over-cure that hole. So larger holes are easier to have that precision and tolerance than smaller holes are. So let's drop down to the 3 millimeter hole. So 3 millimeters in inches is 0.118. Actually, I'm sorry, 0.117. So I'm going to grab the 0.116 gauge, which is right here, and we'll see if this one goes in. And there you have it. So 0.116 is 2.946 millimeters. So again, just with the inch to millimeter conversion, that is a bigger tolerance, but boy, that one dropped right in with no problem whatsoever. And that's, you know, roughly a 50 micron clearance. I don't have one in between 3 millimeters and that to compare against. So maybe let's do the 4 millimeter. That's 0.157, which is right here. All right, so that's 4 millimeters. Let's see if this one goes. So definitely a little tight, but it is going. All right, I think if we were really trying to fit this, we would probably want to drop down to this one. And I don't know the conversion of this one off the top of my head, but you can see that goes very easily. So all of these are very tight tolerances on the hole accuracy. I've also printed, let me grab it. I had also previously printed the Typodont that, you know, I designed and that I sell on my website, and I had designed this to work with pretty much all of my other printers, and the tolerances on it were, I don't know, they were maybe at 0.2 millimeters. And this one, I mean, I haven't touched these at all. This one, that's actually too big of a tolerance. I need to drop it down to like 0.15 or even 0.1, because all of these just can pop right out, and you can actually even see that there's just not enough tightness to the fit right here. Okay, so that speaks to the higher accuracy of this than some of the others that I'm using. Again, look at the detail in the preps. Very nice. No visible layer lines. So anyway, that's a run through of this printer. I'm a big fan of it. Again, lots of very user-friendly features that I'm finding to be very helpful. And so I'll probably do some more videos of doing different things with it, but that's the big picture overview of the whole system. And I'll make some more videos as I do some other things with it. All right, thanks.